Swayam Prabha. Digital India. Educated India.
I am Dr. Rajiv Mishra, working as professor in the Department of Computer Science and Engineering at Indian Institute of Technology, Patna. The title of today's lecture is Introduction to Kubernetes and Docker's Containers. So, let us get started. So, here in preface, that is the synopsis of this lecture is as follows. So, we will be introducing you about the Kubernetes and the Kubernetes context. We will be explaining you about the containers and its orchestration. We will then explain you about the concepts of Dockers and then the power of Kubernetes to deploy the software on the edge devices. Now, let us see the Kubernetes. So, let us talk about the brief about the Kubernetes. Kubernetes is the Greek word for helmsman or a captain of a ship. So, this kind of symbol you might have seen in the ship is being used, and the same ship, you know that the captain guides that particular ship or controls that particular ship operation, and the Kubernetes is the Greek word which is nothing but the captain of a ship. So, Kubernetes is also known as K8s. So, K8 means between K and S, if you count how many 1, 2, 3, 4, 5, 6, 7, 8, 8 different letters are there. So, we instead write K8S. So, K and S we are now including it, and that was called K8S. Kubernetes is also called K8S. So, these are 8 letters, and therefore, it is called K8S. So, Kubernetes was also known as K8S was built by the Google, and based on their experience running the containers in the production. So, it is now an open source project and is one of the best and the most popular container orchestration technology out there. So, Kubernetes is an orchestration container orchestration technology. So, applications grow to span multiple containers beyond or deployed across multiple servers. Operating them become more complex, and to manage this complexity, Kubernetes provides an open source API that controls how and where those containers will run. Now, to understand Kubernetes, we need to understand about the container and its orchestration. So, let us summarize this particular discussion. So, Kubernetes is also written as K8S, is developed by the Google for running containers in the production. When you say containers, that means the applications which are developed these days, they are containerized. And that means they are containerized means applications are now developed in the form of different containers, and these containers will run on the servers, multiple servers. Now, since all the applications which are now containerized, they will be running as the containers on different servers. So, the server orchestration or a container orchestration becomes quite challenging, and Kubernetes is here for container orchestration, one of these technique for container orchestration. Now, we need to understand two important things, one is the container and second is the orchestration, then only we will be able to understand about that. So, let us see about containers. So, what is a container? Container. Now, to answer this particular question, we have to see the virtual machine versus container. So, in virtual machine which we have seen, virtual machine has the following scenarios. It has the hardware and it will be having the virtualization layer, that is called hypervisor, and the hypervisor will now virtualize this environment to run various VMs or virtual machines. Each virtual machine has its own operating system called the guest operating system and the application which is running. Now, then it was thought that why every virtual machine will have its own operating system image running. So, it can be made a lightweight, or this particular virtual machine can become the lightweight where the operating system again can be shared. So, therefore, the improvement says a container. So, container will look like in this following manner. There will be an hardware, and then over the hardware there will be a Docker, and the Docker will manage different container. They are all called container. So, container will not contain no OS will be there, and the Docker will be filling up that particular notion of the operating system. So, this becomes the lightweight of the virtual machine or easy or portable. So, the applications which are written with the help of container, they require the Docker engine to be executing their particular different modules. So, they will be requiring the servers to run that. So, the containers will be deployed on different servers, and to make this particular mapping where these containers are to be running on which servers, and they can be migrated also. So, that is called orchestration, that is called container orchestration. Let us understand these concepts in the more details. So, containers are an isolated environment, have their own processes, services, networking interface similar to the virtual machine, except the fact that they all share the same operating system kernel. So, here you have the container, but there is no OS is there, and it will be now running on the Docker, and the Docker will share the same operating system, that is an operating system kernel, and then it will become the hardware or the server which it is running. But if you compare with the virtual machine, this is the container, but if you compare with the virtual machine or VMs, so in the virtual machines you have an application and here you have an operating system. So, every virtual machine will have its application and its an operating system will have this application and the operating system, and here you have the hypervisor and you have the hardware. So, what you can see in this particular discussion, that if you make a comparison between the virtual machine, this is called VM, and the container, if you can see the difference between virtual machine and the container, So, the operating system, they will have the shared operating system. This operating system is shared and the container will become the lightweight. So, in the same machine you can run more container compared to the number of virtual machines. So, more number of containers can be accommodated, hence the capacity will be increased and rest of the things are same. So, container will have an isolated environment with their own processes like in virtual machine, services, networking interface and mounts similar to the virtual machine, except the fact that they have the same, they all share the same operating system kernel, that is called Docker. So, nowadays you know that the container, most of the applications are containerized and the applications which are containerized in the production requires the orchestration. So, orchestration consists of the set of tools and the script that can help host containers in a production environment. So, orchestration consists of the multiple container hosts that can host the containers. If one fails, the application is still accessible through the others. So, let us see about the Kubernetes, which is a container orchestration. So, Kubernetes consists of one computer that gets designated as the control plane and lots of other computers like here that get designated as the worker nodes. So, each of these, so in this particular example, here you have 3 computers, wherein one computer is running the control plane dedicated, the other 2 computers are running the worker nodes. Now, Kubernetes orchestrates the clusters of virtual machines and schedules the containers to run on those virtual machines based on their available compute resources and resource requirement of each container. So, Kubernetes also automatically manages the service discovery, incorporates the load balancing, tracks the resource allocation and scales based on the compute utilization, and it checks the health of individual resources and enables application to self heal by automatically restarting or replicating the containers. So, now get familiar with each of the Kubernetes component. It is a control plane component. This is called a control plane component, and then we will see the worker node component. Here you can see that user interface, even the command line interface or user interface can directly interact with the control plane, and this Kubernetes control plane has an API server, scheduler, controller manager and etcd. We will explain each and every component of the control plane of a Kubernetes. Now, let us come to the worker node component. So, worker node components, now containers, several containers are grouped together and they are called the pods. So, the pods is the single unit of schedulable entity here in Kubernetes. So, here you can see that worker 2 has 3 pods running, worker 1 has 3 pods, worker 2 has 3 pods, worker 1 pod 1 has 3 containers, worker 1 pod 2 has 2 containers, worker 1 pod 3 has 2 containers. Similarly, worker 2 part 1 has 2 containers, worker 2 part 2 has 3 containers, worker 2 part 3 contains 1 container, worker 2 contains 4 pods, whereas worker 1 contains 3 pods, and here it contains 4 pods. Other than the pods, and each pod will contains the containers within it which it runs. Then it will have the container runtime, it will run, it will have the container runtime, and then it will have 2 more elements. One is called kube proxy, the other is called kubelet. And so, what these components are that we are going to cover. So, first we will see that what are the control plane components, each one by one, what is its significance, which controls all the worker nodes, and within the worker nodes it will control various containers and all the resources which the containers need in the terms of compute, memory and storage. It will be allocated from that worker node resources, and then it will be having 2 more components, kube proxy and kubelet, there inside worker node, and how they are going to be useful, that we are going to tell. So, as the name suggests, kube proxy, that means it is going to give the network access to each container, just like in virtual machine you might have seen that it has also an access to the network component. So, network component of these containers will be handled by kube proxy, whereas kubelet, we will see that what functionalities the kubelet has in case of the worker node component. So, let us start with the components of the control plane. So, the first component is called etcd. etcd is a fast, distributed and consistent key value store used as the backing store for persistently storing the Kubernetes object data, such as pods, replication controller and secrets and the services. These information are maintained here in a consistent key value store. It has the key value store, and this key value store is used as the backing store for persistently storing Kubernetes object data, such as pods, replication controller, secrets and services. So, all the information about these particular elements of the Kubernetes object data, such as pods, replication controller, secrets and services, are stored in this key value store, that is nothing but a database. So, etcd is the only place where Kubernetes stores the cluster state and the metadata that we have seen. The only component that talks to etcd directly is the Kubernetes API. So, Kubernetes API can directly communicate to etcd, and all other components read and write data to etcd indirectly through API server. So, only API server has an access to etcd, and etcd implements the watch feature, which provides an event based interface for asynchronously monitoring changes to the keys. Once you change a key, its watchers get notified. The API server component heavily relies on this to get notified and move the current state of etcd towards the desired state. And the next component of control plane is API server. So, API server is the only component in the Kubernetes that directly interacts with etcd, that I have already told. Now, all other components in the Kubernetes must go through API server to work with the cluster state, including the clients, that is kubectl. The API server has the following functions. Let us see them. Provides a consistent way of storing objects in etcd, provides validation of those objects so that the clients can't store improperly configured objects, provide RESTful APIs to create, update, modify or delete the resource, performs authentication and authorization of a request that the client sends, then responsible for admission control if the request is trying to create, modify or delete resources. For example, always pull default storage class and storage quota. Now, the next part we have discussed the API server, we have discussed etcd. The next part is called controller manager. Now, in Kubernetes, the controllers are the control loops that watch the state of your cluster, then makes request changes wherever they are needed. So, each controller tries to move the current cluster state closer to the desired state. So, the controller keeps track of at least one Kubernetes resource, and these objects have the specified field that represents the desired state. So, controller examples are: there is a node controller, there is a service controller, that is endpoint controller, there is namespace controller, deployment and stateful set controllers. Now, controller manager in Kubernetes controller managers are the loop that watch the state of a system that we have already covered. Finally, the component is called the scheduler. So, scheduler is a control plane process that assigns the pods to the nodes. So, here this is the most important part. Scheduler will schedule, and this is the control plane process that assigns the pods to the nodes. So, here this particular pod 3 is assigned to the node 1, is done by the scheduler. So, this particular scheduler will assign the pods to the node. It watches for the newly created pods that have no nodes assigned to it here. So, for every pod that the scheduler discovers, the scheduler becomes the responsible for finding the best node for that particular pod to run on. So, nodes that meet the scheduling requirement for a pod get called feasible nodes. If none of the nodes are suitable, the pod remains unscheduled until the scheduler can place it. Now, once it finds a feasible node, it runs a set of functions to score the node, and the node with the highest score gets selected. It then notifies the API server about the selected node. They call this process as a binding. So, again let us summarize this. So, important thing is that the pods gets scheduled to the nodes by scheduler. And the nodes that meet scheduling requirement for a pod called feasible nodes, if none of the nodes are suitable, the pod remains unscheduled until the scheduler can place it. Once it finds the feasible node, it runs the set of functions to score the nodes, and the nodes with the highest score get selected. It gets notifies the API server about the selected node. They call it as process of binding. So, there is a process of binding which is an score based allocation of pods to the nodes. So, the node with the maximum score, with the highest score, is feasible, highest score will get selected, and it will be notified. This notifies the API server about the selected node. They call it as binding process. Now, let us see about the kubelet. Kubelet is the component of the worker node. So, worker node component kubelet we are talking about. So, kubelet is an agent that runs on each node in the in a cluster. Kubelet is an agent runs on each node. Each node in the cluster is responsible for everything running on a worker node. So, kubelet is the in charge or a manager which is an agent which is running inside the worker node. It ensures that the containers run in the pod here. The main function of the kubelet service are register the node it is running on by creating the node resource in API server, continuously monitor the API server for the parts that got scheduled to that particular node, and start the parts container by using the configured container runtime. Then continuously monitor the running of the container and report their statistics. Then run the container liveliness probes, restart container when the probe fails, and terminate the containers when their pod gets deleted from the API server. So, that means, let us summarize this, the working of the kubelet. So, kubelet is an agent that runs on each node, and then the node resources as the API server, it will inform about this node resources to the API server, and then it will monitor the APIs for the pods which are now allocated by the scheduler to this particular node, and then it will start the pods, the container over here, and then it will monitor the containers, and then it will also monitor the liveness of the containers, whether the pod is active or not, where the container is running. All these are the responsibility of the kubelet. So, kubelet is having the major functionality of running the pods and container. Now, then next aspect is called service proxy. So, the service proxy is also called a kube proxy. So, kube proxy runs on each node and ensure that one pod can talk to other pod, that is, ensure that the pods communicate, and the container can talk to containers can communicate. It is responsible for watching the API server for changes on the services. For changes on the services and the pod definition to maintain the same network configuration. When the service gets backed up by more than one pod, the proxy performs load balancing across these pods. So, this is all about the service proxy. Now, container runtime. Container runtime, there are two categories of container runtime: lower level container runtime, these focus on running the container, setting up the namespace and the C groups for the container. High level container runtimes is the container engine. These focus on the format, unpacking, management, sharing images, providing APIs for the developer. Container runtimes take care of pull the required container image from an image registry if not available, prepares the container mount, alert the kernel to assign some resources limit like CPU, and pass the system call to the kernel to start the container. So, container runtime is nothing but executing the container in that steps. Now, let us see about the Dockers. So, the most popular container technology out in the market is called Docker container. So, the requirement is to set up an end-to-end stack, including various different technologies like web server using Node.js, a database such as MongoDB, a messaging like Redis, and an orchestration tool like Ansible. So, checking compatibility between these components and the underlying infrastructure, this compatibility matrix issue is usually referred to as matrix from the hell. Thus, with the Docker, one can be able to run these various components in a separate container with its own libraries and own dependencies on the same virtual machine and the operating system, but with a separate environment or the containers. It only requires to build the container Docker configuration with a simple Docker run command, irrespective of what underlying operating system they run. All that need to do was to make sure that they had the installed Docker in their system. So, let us see about the Docker. So, the most popular container technology, as I told you, is the Docker. Docker is an open platform for developing, shipping, and running the application. Docker enables you to separate your application from the infrastructure, so you can deliver the software quickly. With Docker, you can manage your infrastructure in the same way as you manage your applications. By taking the advantage of the Docker's methodologies for shipping, testing, and developing code quickly, you can reduce the delay between the writing code and running in the production. Docker provides the ability to package and run an application in a loosely isolated environment called container. So, let us see about the Docker architecture, how the Docker provides the environment for the container execution. So, Docker is the platform for developing and running different applications which are containerized. So, with the Docker you can not only run the application, but also you can manage the infrastructure. So, by taking the advantage of this shipping, testing, and deploying the code, you can reduce the delay in writing the code and running in the production. So, you can both the things you can do, you can develop and you can run the environment, DevOps and operation part. So, Docker provides the ability to package and run the application in a loosely isolated environment called container. So, it provides the environment for writing the containerized application. Let us see how it can be done. So, let us see about the Docker architecture. So, Docker uses client server architecture. So, here there is a client and here there is a server. So, client server architecture is used here in the Docker as a Docker architecture. So, Docker client talks to the Docker daemon. So, this is the Docker client which talks to the Docker daemon. Which does a heavy lifting of building, running and distributing your Docker containers. So, here all things will be done by the Docker daemon. So, Docker client and daemon can run on the same system, or you can connect the Docker client to a remote Docker daemon. So, maybe the same system or maybe a different system. So, Docker client and daemon communicate using the REST API over the Unix socket or the network interface. So, another Docker client is Docker Compose. that lets you work with applications consisting of the set of containers. Now, let us see about the Docker daemon. Docker daemon listens to the Docker API requests and manages the Docker objects such as images, containers and networks and volumes. So, images, then containers, then networks and the volumes is being managed here in the Docker by the Docker daemon. A Docker is also communicate with the other daemons to manage the Docker service. So, this Docker daemon can also communicate with the other Docker daemon. Now, let us see about the Docker client. Docker client is the primary way that many Docker users interact with the Docker. When you use a command such as docker run like this, the client sends these commands to the Docker daemon. This particular command docker run will send it to the Docker daemon. Which carries them out. Now, this Docker daemon will carries this run command. Now, Docker command uses the Docker API. So, Docker client can communicate with more than one Docker daemon. So, here it has a choice which Docker daemon it is now contacting to. Now, let us see about the Docker registries. So, Docker registry here stores the Docker images like this are the Docker images. So, Docker Hub is a public registry that anyone can use and the Docker is configured to look for the images on the Docker Hub by default. Docker is configured to look for the images on the Docker Hub here, look for the images on the Docker Hub. You can even run your own private registry. Now, Docker objects. So, when you use Docker, you are creating and using the images, containers, networks, volumes and plugin and other objects. Docker desktop. Docker desktop includes the Docker daemon, the Docker client, the Docker compose, the Docker contain trust, Kubernetes, credential helpers for now power of the Kubernetes to deploy the software on the edge. So, architecture here. So, architectural diagram shows the workflow from the cloud through the virtual kubelet through the edge provider down for all your edge devices. So, first the virtual kubelet project lets you create the virtual node in your Kubernetes. And in your Kubernetes cluster, and virtual node is not a virtual machine, it is most like the nodes in the Kubernetes cluster. Instead, it is an abstraction of a Kubernetes node that is being provided by the virtual kubelet. So, backing it as an IoT hub, it can schedule the workload to it and treat like any other Kubernetes node. So, when the workloads are scheduled to this virtual node, the edge provider comes in, that is being depicted. So, the edge connector or the edge provider edge connector or the edge provider which are working in tandem with the virtual kubelet, it takes the workload from a specification that comes in from Kubernetes and converts it into an IoT edge deployment. So, IoT edge deployment is shipped back to the backing IoT hub for this virtual kubelet. Lastly, the IoT hub in turn pushes its deployment down to all the target devices. So, this you can understand here that this is the Kubernetes pod and this is the devices. So, all these particular devices will get deployed the IoT edge runtime, and then the Kubernetes and the kubelet then it will run the virtual kubelet on these particular devices, as a pod, and within the pod it will run the containers on the device, on the premise, the edge devices. So, conclusion: in this lecture what we have discussed is the Kubernetes, and we have also seen the Kubernetes as a container orchestration. We have also defined the container, which is nothing but the lightweight system for running the applications, where operating system is shared in the Docker, that means engine, which is supposed to run the containers, as we have seen the hypervisor in the virtual machine. So, as the applications are containerized, lot of containers are supposed to be running on the servers for different applications. So, it requires a orchestration, container orchestration. We have seen the Kubernetes, how it runs the containers. Containers are running inside the pod. So, pod is the minimum schedulable entity, and these pods are running inside the nodes which Kubernetes will schedule as per scheduler is concerned. It will monitor them and so on. So, the concept of Dockers we have also seen, the power of Kubernetes to deploy the software on the edge devices we have seen. So, what we have seen in this particular lecture is about the Kubernetes, how it is going to orchestrate the container applications, and these container applications are very much needed to run on the edge, that is on the nodes, and the container orchestration is done through the Kubernetes. So, these kind of detailed discussion are very much needed in building up the edge computing system. We will see more details on the further lecture. Thank you.